10, 9, 8, 7, 6. Go for main engine start. Main engine start. 2, 1. Booster ignition and liftoff of the.
That was the launch of the Space Shuttle Discovery in 2006. With only 4 missions remaining of NASA's 29-year Space Shuttle program, and Obama pulling funds for the replacement Constellation program, if we wish to continue our exploration of space, we must find an alternative to these expensive, fuel-consuming rocket launchers. One exciting idea is to build a space elevator. Although it sounds like something from a science fiction novel, it might be possible to transport material along a fixed structure that reaches from the equator of the Earth to a point of geostationary orbit. The elevator would consist of a cable or tether that is anchored to the Earth, balanced by a counterweight that is beyond geostationary orbit. The space elevator cannot work like the ones you and I are used to here on Earth. Traditional elevators employ moving cables to transport carriages. However, this is not possible with the space elevator, as the cable must be significantly wider at the center than at the extremities. This means that the cable of a space elevator must remain stationary, with climbers crawling up and down the tether to transport material. These climbers are powered via lasers from Earth. So, the space elevator seems like a potential replacement to expensive rocket launchers. However, there is a fundamental problem with the concept. This is due to something known as the Coriolis force. A Coriolis force deflects objects that are moving in a rotating system. In this case, the rotating system is the Earth. The rotation of the planet sets up this force, and as a climber ascends the tether of a space elevator, its upward motion causes this to pull the climber and the tether in the opposite direction to the Earth's rotation. This results in the cable oscillating back and forth, and although it may only move by a fraction of a degree, the orbits of spacecraft exiting the elevator would be many kilometers too high or too low. To circumvent this problem, we can disconnect the terminal that is fixed to the Earth's surface. In other words, we can build a floating space elevator. In this instance, the space elevator will be in orbit around the Moon. It is not fixed to the surface, as there is no point close enough to the Moon for a space elevator to be in geostationary orbit. To prevent the terminus of the elevator from crashing into the lunar mountain peaks, the tether will end 10 kilometers before it reaches the regolith. To span this 10-kilometer gap, an astronaut would be fired in a magnetically levitated train along a track on the lunar surface. The gradient of the track gradually increases until it becomes vertical. The train must be fired so that it leaves the vertical track just as the terminus of the elevator passes overhead. A robotic grappler on the terminus catches the train and then attaches it to the tether of the elevator. In theory, a lunar space elevator is an exciting project. However, at the moment, all that remains is theory. There is currently no material strong enough to handle the strain that will be placed upon the tether of the elevator. Using carbon nanotubes is a possibility, but for this, the nanotubes must be much larger and much purer than any that can be manufactured today.